Okay, for this one, the first thing we want to do is express this in its vertex form. So to do that, we have to complete the square. Remember, to do that, if there's any constant here that is other than 1, then you have to factor it out of those first two terms. So let's do that. Factoring a negative out gives us x squared plus 10x. And then you can complete the square on the stuff that's in the parentheses there. So to do that, you got to look at that second term. It's 10. The constant is 10. The coefficient is 10. So half of that is 5 squared, 25. So plus 25. And don't forget that you also have to subtract 25 from within the parentheses. Then those first three terms are a perfect square trinomial, so they factor to be x, in this case x plus 5 squared. And remember how you do that. You look at the third term there. Square root is what goes here, and then whatever sign that has is the sign that goes here. So that was just the first three terms that factored into that. We still have a minus 25 there, and then we still have the plus 1 on the end. So our last step here is to distribute this minus back in. If you do that, you get negative x plus 5 squared, and then that becomes plus 25, and then plus 1 more, plus 26. So that answers part A. And then for part B, it says identify the vertex. So now that it's in vertex form, it's very easy to see that the vertex is at minus 5, 26. And remember, this will be a parabola opening down because it's got a negative leading term. Find the x and the y-intercepts if there are any. Okay, so for part C, x-intercepts, we have to set this whole thing equal to 0. So that gives this. But when you set them quadratic equal to 0, it's often easier to have the leading coefficient be positive. So if you multiply both sides of this by negative 1, you get x squared plus 10x minus 1. Okay. So then, let's see. We want to, I don't think this is going to factor, so we'll have to use the quadratic formula on that. In fact, actually, you don't even have to use the quadratic formula if you don't want to. We could have set this equal to 0 just as easily. In fact, that's a little bit of an easier way to do this. So if let's do that instead. We'll set negative x plus 5 squared plus 26 equal to 0. Quadratic formula would work here, but I think this is going to actually be a little bit easier. So if we do that, we're going to get x plus 5 squared is equal to 26. And then you take the square root of both sides, you get x plus 5 is equal to plus or minus square root of 26. And finally, you can just subtract 5 to get our two final answers here for the x-intercepts. Minus 5 plus or minus the square root of 26. So if you want to write this as points, the first point would be minus 5 minus root 26, 0. And the second one would be minus 5 plus root 26, and 0. Then the y-intercept, the last step. Oh, that's graphing is the last step. The y-intercept, get rid of this. Y-intercept is just f of 0, so if I plug in 0 to that original function, you see what's left is just a 1, so f of 0 is 1. And it would probably be helpful to go ahead and approximate these so that we can get a better picture of the graph. So when I plug this into the calculator, I get minus 5 minus root 26 is about negative 10.1. And then when I do the other one, it's about 0.1. So those are two approximate x-intercepts, and there's our y-intercept. Finally, to graph the thing, putting this all together, look at these x-intercepts. They're one large negative 1, and then the y-intercept is only 1, so this is going to be a little bit weird to graph. minus 526. Let's just approximate this. We'll say this is minus 5. Say this is 26 up here. There's our vertex. We have our two x-intercepts. One's really close to 0. We'll just put it about right there. A little bit right at 0 almost. The other one's at minus 10, so that'll be about maybe over here. And then make sure it goes through those points. And it kind of at least looks like a parabola. Probably better than my drawing here, but anyway, I get the picture here. So that's the graph and everything else.